My name is Christian Adamo, and I'm here to talk about our experiment on spectroscopy using IR and NMR. So first, what is spectroscopy? It is a study of the absorption and emission of light and other radiation by matter. And for this experiment we use two forms, and that is IR and NMR. For IR, infrared spectroscopy, this is the analysis of infrared light interacting with a molecule. It's measured by absorption, emission, and reflection. And this is an example of a spectrum for IR. With this, we have the range of absorptions. And so say, for example, we take a carbon-hydrogen bond from 3010 to 2800. We can use this spectrum and see that there is a carbon-hydrogen bond in this spectrum. For NMR, nuclear magnetic resonance, this is a technique of determining the structure of organic compounds. We refer to this sometimes as the number of peaks and the ratio of eras the compound has. So for this, for example, methanol has 2 peaks and a ratio of 3 to 1, and so on. An NMR example, say we take methanol, that's its form, the H3C bonded to an OH. We see that it has 2 groups, a hydrogen and a carbon bond, and an oxygen-hydrogen bond, giving it 2 peaks. And then for the ratio, we see that in each group, for the hydrogen-carbon, it has 3 hydrogens, and the oxygen-hydrogen, 1 hydrogen, giving it a 3 to 1 ratio. My unknown was 13I, and these are the NMR and IR spectrum used for the 13I. I used the range of absorptions to find what bonds it might have, and I found that it has a carbon-hydrogen single bond and a carbon-oxygen double bond. From there, I narrowed it down to 4 using the IR, and so I had to use the NMR as well, which was a ratio of 3 to 2 to 3, and the only one left was ethyl acetate. And this is how I matched them up. My 13I matches with the ethyl acetate for the IR and with the NMR, concluding that it is ethyl acetate.